Alright, we'll be doing a systems of inequalities, very similar to graphing inequality, only you're graphing two now on the same graph. So in this graph, we have a less than or equal to sign and a greater than or equal to sign, which means my lines are going to be solid. If they were just less than or just greater than, the lines would be broken up or dotted, but less than or equal to, greater than or equal to, we have solid lines. So all I'm going to do is I'm going to take each equation separate, or each inequality separately, and solve for y. So we subtract 2x, we divide everything by 4, and y is less than or equal to negative 1/2 x plus 1. My y-intercept is 1, my slope is negative 1/2, so up 1, left 2, down 1, right 2, and I draw my line. We'll get to the shading later. Then my 3x minus 2y is greater than or equal to 6. We're going to solve for y again. We're going to subtract 3x on both sides. We're going to divide everything by negative 2, which means we're going to flip the inequality. It's not really going to make a major impact on the answer, but it's still the correct thing to do is to flip the inequality when you divide by a negative, so let's be consistent. We get a slope of 3/2 and negative 3. So my y-intercept negative 3 and positive 3/2 is my slope. Up 3, right 2, up 3, right 2, or down 3, left 2. And I draw that line. And now I need to shade. Always use the point 0, 0. 0, 0 is true, you shade toward it. If 0, 0 is false, you shade away from it. Never up or down, away from 0, 0, towards 0, 0. So my first equation, 2 times 0 plus 4 times 0 is 0, and 0 is less than 4, so we shade toward it. Next equation, 3 times 0 minus 2 times 0 is 0, it's greater than 6, that's false, so we shade away from it. And the answer is where the shading intersects. If you really want to check, over-exaggerate a point in that double shaded area, like 0, negative 10. 2 times 0 plus 4 times negative 10 is negative 40. That's less than 4. 3 times 0 minus 2 times the negative 10 is positive 20, and that's greater than 6. So we're correct.